Precalculus algebra video, and here we're going to look at the sums, differences, products, and quotients of functions. So let's say that you were given two functions. The first one is f, and let's say it has domain a. So a is the set of numbers for which f is defined. And you have a second function, call it g, and b is the set of numbers for which g is defined. From these two functions, you can create four functions by adding, subtracting, multiplying, and dividing the functions that you were given. So first of all, if you want to add the two functions together, so if you want to create a new function called f plus g, it's exactly what you think it is. It's simply the sum of f of x and g of x. So what you do is you simply add the functions together. Now the domain, that is where this sum is defined, let's go ahead and write that over here. Now, what has to be true? Well, if you're adding these two things together, then they both have to individually be defined, right? Like we need f to be defined at x, and we need g to be defined at x. So the domain is going to be, the domain of the sum is going to be the intersection of the two domains. In other words, we need both functions to be defined in order to add the two functions together. So the domain of the sum is going to be a intersect b. So what you do is you find the individual domains and you find the overlap of those two domains, and that's where the sum is defined. And likewise for the difference. The difference of two functions, f take away g, you get that by simply taking f and subtracting g, and you can do that anywhere both f and g are both defined, and that's why the domain of that difference is a intersect b. And likewise for multiplication, to get the product of two functions, we multiply the two functions together, so we get f of x multiplied by g of x. And once again, that's defined anywhere the two functions are defined. And the only one that's different is the quotient. So if you want the quotient of f and g, what you do is you do what you think you do. That is, you take f, the rule for f, and you divide it by g. And it's true that you need both of those to be defined, right? You need numbers for which both f and g are defined. But there's another issue here, and it's that sometimes you can have a value where g is defined, but the value of g is 0. And we don't want that, right? We don't want an input where g gives the value of 0, because then the denominator of this fraction will be 0. So what we say is, not only do you want everywhere f and g are defined, you also want to make sure that g of x is not equal to 0. So you have to exclude any numbers that cause g to be 0. Even if g is defined there, g is not allowed to be 0 for this quotient to be defined. Okay, let's see how this works within an example. Let's say that you were given, so this says let f of x be equal to 1 over x minus 3, and g of x equals root x. We want to find the sum, the difference, the product, and the quotient of those functions and their domains. So the first order of business is to write down the domains of the functions individually. So the domain of f, well, f can, you can plug any number you want into f except for 3. So let's just write x cannot be equal to 3. That's the domain of f. For g, the domain of g, what's true? Well, you can plug in any number greater than or equal to 0. X is greater than or equal to 0. So these are the two individual domains. And then we can create these new functions and look at their domains. So to create the sum of those two functions, like we talked about, all you do is you simply add them together. So it's going to be f of x plus g of x. And so what's f of x? Well, it's 1 over x minus 3. And we're going to add that to g of x. And what's g of x? Well, it's the square root of x. And what's the domain of this function? That is, where's this function defined, the sum of these two? Well, like we talked about, because we're adding these two, it's the intersection of the two individual domains. So it's the intersection of these two sets. So we want both conditions to be satisfied. So we want x to not be equal to 3, that's one condition, and, right, that's intersection, means that you want both conditions to be satisfied, x to be greater than or equal to 0. So that's the intersection of those two domains. And then for the difference, f take away g, that's likewise going to be f of x, take away g of x. So f of x is 1 over x minus 3, and from that you want to subtract off g. So we're going to subtract off the square root of x, and the same domain. X cannot be equal to 3, and x is greater than or equal to 0. So actually, when you put these together, we're basically talking about all the numbers greater than or equal to 0 except for 3, right? So I wrote it like this, but that's really what we're talking about. Okay, then the product, that is f multiplied by g, you simply take f, which is 1 over x minus 3, and you multiply it by the square root of x. Okay, and that ends up being, you can just put the square root of x divided by x minus 3. And then once again, we have the conditions, the domain that x cannot be 3, and x has to be greater than or equal to 0. And then finally, the one that's a little tricky, if you want to take the quotient of those two functions, what you do is you take f and you divide it by g. So in this case, it's going to be, well, f is 1 over x minus 3. That's in the numerator, right? And you're going to divide it by g, and g is the square root of x. And when you perform that division, what you get is this. The x minus 3 comes in the denominator, and you get 1 over, it's going to be root x times x minus 3. And what's the domain? Well, just like before, you do have this condition, right? It is important that x cannot be equal to 3. That's one condition. And x has to be greater than or equal to 0. That's true for sure, right? You need both of those conditions because that's the intersection of those domains. But you also need the extra condition that g of x cannot be 0. So g of x is in the denominator here. And what number causes g to be 0? Well, 0, right? Because the square root of 0 is 0. So you have this extra condition. It's not that g isn't defined there. G is defined at 0. But the problem is that when you plug in 0, you get 0 in the denominator and makes that whole fraction undefined. So not only do you have these two conditions, you also have the condition that x cannot be 0 because that causes g to be 0. So when you put all these three things together, you see that, well, x not equal to 3, x greater than or equal to 0, but x not equal to 0, that means that it's not just greater than or equal to 0. X cannot be 0. So you get this for your domain. X cannot be 3, and x is strictly greater than 0. We don't have the option of x being equal to 0 for the reason we just mentioned, okay? So that's the domain of this new quotient function. Okay, and like we talked about, you can also combine two functions f and g using an operation called composition, and that's covered in another video. Until next time.